Come on, gentlemen, let's go. Work on your review card. What? Let's see how superior you are in your review ability. All right, so here are your converses. If you wear a sweater, then you are cold. If an angle measures 90 degrees and the angle is a right angle. The converse of a true conditional statement is sometimes true. Would you consider this one true or false? Do you know people who wear a sweater and they're not cold? Maybe he's trying to sweat it out.
I don't know. It's been
But there are people who wear a sweater and they're not cold. Well, there are some people that are allergic to the sun. Like they can't be exposed to the sun. Or they're albino and they can't. It's possible. I have known people like that. Alright, so let's look at our vocabulary word of the day. We don't know what happened. Oh, there's my color. Exterior. By this time you should know what exterior is. The outside. Yesterday we looked at interior, so today we're looking at exterior. So it's the outside of the parallel lines. So to paint the outside of your house, you buy, oh, that's a toughie, exterior paint. You could buy interior paint to paint the outside of your house, but how well is that going to work? Not well. It's not going to last very long. The protective cover prevents the blank of the book from being damaged. I would imagine it's the exterior of the book. In the diagram at the right, angles 1 and 7, they are on the exterior, so they are alternates. Do we have a choice of choosing alternate or angles? Yeah. Oh, you can too. Thanks. Yeah. Yeah. If you don't have a hardcover, let's say you had a soft cover book, then I could agree with you. But there are some people that want to make that hardcover clean. The hardcover itself is protecting the exterior. The cover on the hardcover is protecting the cover of the book. Oh, is that what you were thinking? That was a hardcover of the book? Oh, I understand. Gotcha. Yep.
It's kind of off subject, but when you do a converse, you use like a rundown in case of you have the second part.
Yes.
So you can say like the angle of 90 degrees is a way. Instead of saying the angle.
Yeah. Yes, you could. All right. Any other questions before we continue? Okay. The diagram at the right, angles 4 and 5 are what? Same side. Those are the interior. I don't think we need to underline the hypothesis and the conclusion. What do you have to worry about when you underline the hypothesis and the conclusion? You do not include the if and the then, right? Okay. So let's flip. and so this has to go on a flashcard. This is another theorem. Corresponding angles theorem. So if a transversal intersects two parallel lines, then corresponding angles are congruent. Don't we already know that? Right? And in theorem 3-4, the converse of the corresponding angles theorem. If two lines on a transversal form corresponding angles that are congruent, then the lines are, we can say here, what's missing? If two lines on a transversal form corresponding angles that are congruent, what do you conclude about those two lines? No, they're parallel. Right? So here's the reason for the converse. If you're going to try to prove lines parallel in this section, rather than prove certain angles congruent or supplementary. You're going to use your knowledge of the angle relationships. And if you happen, because remember, those angles are called corresponding angles, or same side interior angles, or alternate exterior angles, or corresponding angles. They're all called that no matter whether the lines are parallel or not. Because we saw that in 3-1, right? But then in 3-2, all of a sudden when the lines became parallel, then those particular angles were either congruent or supplementary. So now we're going to go in the converse of that and say, okay, here is a set of two lines cut by a transversal. There's nothing here that says that these two lines are parallel, but you could prove it if I prove to you that those angles are congruent. What kind of angles are those? Corresponding. If I told you that these two angles were congruent, because they are corresponding angles on two lines cut by a transversal, your conclusion now is in the converse that, oh, well, then those lines must be parallel. So we're just doing it in reverse, and that's what this is trying to tell you. So we place appropriate markers showing that they're congruent. So then at number 12, circle the diagram that models theorem 3-4 that says if two lines on a transversal form corresponding angles that are congruent, then the lines are parallel. So which one shows corresponding angles that are congruent? This one or this one? The second one. What is this one showing? Alternate exterior. Can I prove parallel lines when alternate exterior angles are congruent? Are alternate exterior angles congruent on parallel lines? Yes. So I could prove the same one is parallel, but I'd have to say, I'd have to do the converse. If alternate exterior angles are congruent on two lines cut by a transversal, then those two lines are parallel. So I can use that. I can use everything from 3-2 as a converse. All right, look at 3, 5, 6, and 7. So this is the converse of the alternate interior angle, same side, and alternate exterior angle. So they're all saying the same thing. And here is your shorthand notation. So look at the picture. If angle 4 is congruent to what? We want to use 3, 5, so we want alternate interior angle. So what's an alternate interior angle to angle 4? 8. So this would be angle 8. So this is what you would put in the reasons column. With angle 4, no, that's not what you would put. You would put this in the statement, and then this would be your second statement. What would be your reason for this? You would go from here, and then you could prove that the lines are parallel. Would you say that if 4 and 8 are alternate interior, so if alternate interior angles are congruent on two lines cut by a transversal, then those lines are parallel? That would be in the reason column. This would be one statement, that would be the statement column. So for 3-6, we want same side interior. So what's same side to angle 3? Angle 8. Notice that this time, it's supplementary. Remember, same side angles are supplementary. So if you can show that the same side angles are supplementary, then you can prove that the lines are parallel. And then 3-7, we want alternate exterior. So what's alternate exterior to angle 1? So angle 7. All right, so what does that look like? Problem 1. And we're only going through to problem 2 today. So which lines are parallel if angle 6 and angle 7 are congruent, and justify your answer? So underline the correct words and the sentence. Angle 6 is congruent to angle 7. Is that given, or is that what you have to do? This is given. So I would mark over here on my picture, angle 6 is congruent to angle 7. What do you conclude from those types of angles, by the way? What kind of angles are they? They are corresponding. So angle 6 and angle 7 are alternate or same side angles. They are same side. They're not same side interior, but they are same side, okay? That's what they're trying to get you to. So they are same side angles. Same side of the transversal. Angle 6 and 7 then, are they corresponding exterior or interior? So we already determined that they're corresponding. So remember, you're not to memorize their numbers. I have no idea what 3, 2, and 3, 4 are, but you'll have to go back and look them up. What theorem can we prove then? Really is the corresponding angles to them, right? So we're going to just totally cross that out and just say corresponding angles theorem. But you're not to use that as a reason. We're just going to put that in there to jog our memory of what that means. Because we can write it in the converse or in the true condition, whichever one suits our purposes. If I'm trying to prove that lines are parallel, I'm using the converse. If I'm trying to prove angles congruent, I'm using the true condition. So using angle 6 is congruent to angle 7, lines what are parallel. This is a transversal, so it's cutting through line M and line L, right? So line L and M are parallel. And the transversal is what? If you trace your angles, you will be tracing that transversal line. So as I trace from angle to angle, I'm tracing line B. And so line B is your transversal. And so for some of you that's hard to see, I know others of you like, you're kidding. They can't see that this is a transversal? No, they can't. Because their brain is wired differently. It doesn't mean that their intelligence is lower than yours. It's wired differently and they don't see things the same way you do. That's all that that means. Okay. So you're going to be introduced to something called a flow-through proof. It's more of diagramming. A lot of businesses use flow-through analysis. And a theorem 3.6. So if you look back here for theorem 3.6, we are doing same side interior angles. You might want to put that on here. Same side interior angles. So we're going to use the diagram at the right and the fact that they gave us that angle 1 is congruent to angle 7. If they hadn't marked it, I would. What kind of angles are those? Do they have a relationship? Alternate exterior angles are congruent. So from here, I actually can prove that the lines are parallel based upon alternate exterior angles, can't I? But I don't know if that's what they're going to do here, because we want to prove that angle 3 is congruent to angle 5. Have we been told that the lines are parallel at all? No. It would be nice to do that at some point, but we do have to use same side interior angles somewhere, so we'll get to that. And so this is what we're proving. Notice that that's our last statement here. So underneath each of the boxes, there is a verbally written reason. So your statements go in the boxes, and your reasons go underneath. So our given was only one thing. Angle 1 is congruent to angle 7. From this, they're saying we can conclude that angle 3 is congruent to angle 7. Why? We'll have to come up with a why. And then also angle 1 is congruent to angle 3. Oh, why? Yeah. So vertical angles are congruent. So then we're going to put a marker here. So if 1 is congruent to 7, so look at what is flowing into the fact that we concluded that 3 was congruent to 7. So if 1 is congruent to 7 and 1 is congruent to 3, then they said that 3 was congruent to 7. Why? Is it the proper use of the transitive property? What we ended up here, is that what we started with here? No. So if it's not the proper use of the transitive property, but it looks very similar, what do we use instead? Substitution. I'll bet you your book is going to say it's the transitive property. I wholeheartedly disagree. So it's the substitution property of equality. Yes. Because let's write it vertically. If I have angle 1 is congruent to angle 7, and then I have angle 1 is congruent to angle 3. I have two angles congruent to the same angle. I can conclude then that those two angles must be congruent. And so because what I end up with here, I didn't start with here. If this given had been written in the reverse, it had been instead written this way, angle 7 is congruent to angle 1. Then what I end up with here is what I started with there. And we can put those two together. Of course, I'd have to start with angle 7. That would be the property of the transitive property. So when they either start with the same number or end with the same number, we can use substitution to replace them instead. Yes.
This is kind of a general question, but when they're doing the same question, do you think that they would use like that instead of?
It'll be interesting to see. My guess is that they would, because I've seen it that way used interchangeably in other textbooks as well. I am more of a traditionalist, so I'm going to stick to that one, because that way you see that there's a difference between the transitive property and substitution. But yeah, that'll be an interesting question to see. I don't know. You could have people grading your open response of your math tests that are math people. It's just like the people that grade your English test and the English test. They're not English majors at all. So it's interesting that you get the scores that you do on those. But that digresses. It's a whole other conversation. All right, so now we've gotten to the fact that 3 and 7 are congruent. Remembering that we're trying to get 3 and 5. I haven't gotten 5 into my proof yet at all, right? Then they mentioned vertical angles are congruent. What angle is vertical to angle 7? That's how we pull 5 into the proof. We've got to pull these two things into proof so that we can get them congruent to each other. So angle 5 is congruent to angle 7 because vertical angles are congruent. Then, how do we go to our proof statement? So again, off to the side, I'm going to show you what we have. We have 1 is congruent to 3. Nope, that's not it. I want 3 and 5 and 7. 3, 5, and 7. So here we go. So look at these ones vertical. Angle 3 is congruent to angle 7. Then on this one, angle 7 is congruent to angle 5. So then your conclusion is that angle 3 is congruent to angle 5. What is that a use of? 3 is equal to 7. What you end up with here, you start with here, 7 is equal to 5. You put those, that is the transitive property, right? Because these, what you end up with here is the same as what you start with there. And so this is the transitive property of equality. And so we're going to stop there. Your homework is on the board. Do your best. Come with questions on Monday. We will finish the lecture on Monday.